2 years. I am what you would consider a nerd when it comes to science and math, especially theoretical physics and mathematics, but that is a whole other talk altogether. I love it, and it's through a scientific and mathematical lens that I have been helping CR2 develop data analysis methods and solutions to regenerate coral reef ecosystems internationally. We have a problem. This problem is that coral reefs around the world have gradually become extremely unhealthy, and even in many cases, disappeared entirely. So you may be asking yourself, what is a coral? Corals are marine invertebrates in the class Anthozoa of phylum Rosaria that typically live in compact colonies of many identical individual polyps, like the one shown here. Corals include the important reef builders that secrete calcium carbonate to form a hard skeleton. Here's a coral reef. It is jam-packed with biodiversity and just teeming with life. Coral reefs provide a home to nearly 25% of all marine fish species. A single square kilometer of coral reef can be worth up to $1.2 million in the fish that it provides, its value in tourism, and prevention of erosion and storm damage. However, destructive resources such as blast fishing can efficiently and swiftly destroy titanic amounts of natural habitat, which can result in once pristine coral reef habitat looking like this. And like all natural resources, there's only a set amount of healthy coral reef habitat in the world. And we as humans can easily deplete the oceans of its coral and its fish much faster than it could ever hope to regrow. And this does not always happen directly through practices such as blast fishing. Heat waves can cause coral to be stressed, and when coral is stressed, it ejects the single-celled algae that provide the coral with 90% of its food. The coral in algae, zooxanthellae, is different from chlorophytes, or green algae. In 2005, extreme heat and increased storm activity caused a record amount of coral bleaching, and today annual coral reef bleaching rates are steadily increasing. This plot from the same report shows a marked increase in the amount of microalgal cover during the period from 1970 through 1998. Looking at the plot, you can see that it increases from approximately 8% to approximately 23%. This is accompanied by a dramatic decrease in the percent coral cover, which then continues following 1998, from 35% initially all the way down to only 16% by 2011. The next question you might ask is, how can we save them? Well, there are several methods being employed by organizations such as Reef Check, NOAA, and Coral Point Diving. One of the most popular and most successful conservation methods is the establishment of coral nurseries, which are structures with small fragments of branching coral attached to them. As corals can asexually regrow from fragments, this will, over the course of a few years, create large amounts of healthy coral. This coral can then be retransplanted back into reefs, creating healthy reef ecosystems once again. Innovative conservation methods such as these are very important. The Reef Check website allows you to access an extensive online database of over 8,000 surveys collected by Reef Check volunteers worldwide. The fact that it's so free and so open and so valid allows extensive analysis to take place on the state of our coral reefs. It has an easy-to-use and intuitive interface that allows you to see distribution heat maps over time, certain species in certain areas, and download results from surveys in Excel format. This allows you to see trends in the data, such as this. This graph shows the average percentage of bleached coral found during Reef Check surveys of the Atlantic from 2003 to 2013. You can see that the amount of coral bleaching increased dramatically in 2005 to 2007, which matches exactly the time and effect of the heatwave data shown earlier. However, those data were collected by a team of trained scientists from the International Coral Reef Initiative, and these data were collected by trained Reef Check volunteers. From this, we can see the importance that open data can play on 21st century conservation efforts. These data may be used to monitor the health of reefs and the effects of conservation efforts in real time. This data is available not only to scientists, but to anyone who wishes to access them. And unlike other citizen science projects, the volunteers are trained and certified, which ensures accurate data collection. Parrotfish are a natural solution. They are extremely important since they eat algae, which can prevent dangerous algae overgrowth, which can destroy coral reefs. Parrotfish populations need to be kept alive, since they can make all the difference between an algae bloom and a healthy coral reef. This is a graph of the average number of parrotfish found during Reef Check surveys of the Atlantic during the period from 1997 to 2013. As you can see, the average number of parrotfish found during reef check surveys has been steadily declining from its peak at approximately 2.4 per survey in 2003 to approximately 1.6 per survey in 2013. These reef check data are valuable in documenting the amount of parrotfish in specific locations, such as marine protected areas. We founded the Coral Reef Regeneration Project, CR2, in the fall of 2012 as a unique way of conjoining the study of marine science and Caribbean art history, with real hands-on opportunities to conduct fieldwork with the Reef Check Dominican Republic. In the spring of 2013, we spent 2 weeks in the Dominican Republic working with Reef Check DR Director Ruben Torres to collect reef check data, set up coral nurseries, and cull invasive lionfish populations. Over the past year, the scope of our project has expanded to include the construction and use of an ROV, or underwater remotely operated vehicle, through a grant provided by the Motorola Foundation and the Shed Aquarium.
Hi, I'm Fiona Rubb, and I joined the CR2 ROV team in 2013 and traveled with the team to the Dominican Republic in April of 2014. I'm interested in restoring the Dominican coral reefs in a way that's sustainable and culturally sensitive to the Dominican people. I take an interest in engineering and biomimicry, which are topics the whole team learned about during the design and building process of the ROV. CR2 chose to attack elements of the overall problem. How did we go about doing that? Team members traveled to the DR and began surveying the reefs and reconnecting with valuable local contacts. We also designed and built an underwater ROV with the support of Chicago's Shed Aquarium and the Motorola Foundation. This was our first design. With the ROV, we could take close-up images of the reef and give members unable to dive access to the reef in real time and through video. Our idea is to eventually set up kits that a bunch of kids could assemble to make their own ROV. We would make them and bring the kits to schools in the Dominican Republic. That way, young new generations there can get to know the greatest resource better and learn to take care of it. Here the ROV is set up for shallow diving, with pool noodles used for buoyancy. For our deeper dives, we had to use sealed PVC tubes as foam crushes under pressure in deeper water. The ROV is driven by a pilot with a switch box on the surface end of a 50-meter tether to control the 4 motors. An underwater fish TV system helps the pilot see where to go. We also attached underwater cameras to record footage. There are programs like the Shed Aquarium's Underwater Robotics Design Competition. Lots of schools have already caught on to the idea. Most of the other teams built their ROVs to compete in a competition that would take place in a swimming pool, but we received permission to alter our specs to accommodate a deeper dive in the ocean. The Shed people were thrilled and very helpful, hoping that eventually all teams would be encouraged to take their new ROV knowledge and use it to perform scientific exploration.
Here's a picture of me and some other CR2 team members examining a marine protected area in the Dominican Republic, where the mangroves, native forests, and underwater grasses are preserved. Here we found shoreline communities and reef are thriving. This is thanks in large part to the environmentally conscious local community, which has fought to keep these areas undeveloped. An ROV can offer a chance to review a transect via video, which allows for greater survey precision, and it can provide an experience for the coral reef of the coral reef for those who cannot scuba dive and those who do not have access to coral reefs. It can also provide water and sediment samples at different depths. The Reef Check protocol for surveys gathers data on indicator fish, invertebrates, and substrate cover. The surveys are taken along 20-meter transect lines. Each orange box represents one transect. The full survey includes the collection of data across 4 transects, with mandatory 5-meter breaks in between. Divers document the fish, invertebrates, and substrate cover using waterproof paper, underwater tablets, and pencils. Yes, we do exist. Data is then checked for accuracy and entered into the Reef Check database through an online interface.
Now, we've all seen pretty photos of coral reefs. They're colorful and full of life. These are some stills from a photo we took on CR2's most recent trip to the Dominican Republic. But what do we see? Sure, there's coral. We can see multiple kinds of fish. But that's still not a healthy reef. So, why is the reef like this? Well, as you heard, the reef is under attack from a few places. I'm going to zero in on a couple of these. A major threat to reef health is lionfish and other invasives. This is USGS's photo of lionfish. Females can lay up to 2 million eggs. They'll eat anything that can fit into their mouth. They can live without food for 3 months. And to top it off, they have no natural predators in the Caribbean. According to NOAA, one lionfish can deplete over 80% of the other life forms in the area in 5 weeks. They have venomous spines, and their stomach can expand to 30 times its original size. Lionfish are a current threat to all of North and Central America. Recent scientific studies can tell us they can thrive in freshwater too. So, pretty scary, right? What are we we going to do about it? Well, a way to help with an invasive species that happens to be tasty is teach people how and why to catch it and eat it. Education is key here, as many divers do not know that this attractive species does not belong in the Caribbean. Here's a shot we took of team member Matthew Shum dissecting a small lionfish to gather data. Data is only as good as the training of the scientists. Our team learned about the value of citizen science versus trained science, and how certifications in fish identification and transect surveys can improve the accuracy and validity of the data so that it can be used by other scientists. So, we've got invasives to deal with. But another problem is runoff. Places like resorts, cattle farms, and sugarcane farms create nutrient runoff. Untreated sewage is pumped into the ocean, packed with nutrients and potential pathogens. And if a facility also plants non-native species, they have to use a lot of water, fertilizer, and pesticides too. Let's start with a basic life form on the reef, algae. When nutrient-rich runoff gets into the water, the less favorable green algae goes nuts, and it causes oxygen levels to drop. The algae grows faster than the creatures who eat it can keep up, thus clogging the reef, blocking sunlight, and disrupting the balance. Beaches are cleared, so runoff is no longer filtered by shoreline communities like trees, grasses, and mangroves. Beaches create and protect the reef that the resorts thrive on. Since the reefs are no longer protected from runoff, the system it's far from sustainable. However, doing away with the beaches is not a sustainable solution for the Dominican people. Tourists attracted by the beaches help drive the economy. The answer is to balance protected areas with resorts to employ environmentally sound design. Our team will continue to support businesses within the DR that are sustainable and work within the Dominican culture in a sensitive way. With the resorts, we didn't get much of a picture of Dominican life with them. After adjusting to the local activity, we actually preferred to be at places like the dive shop called Coral Point Diving and this hotel called Hidalgo Caribe Colonial. This is the one-room schoolhouse our team visited on Isla Salina. Here, team member Matthew Shum shares photos of coral reef fish and invertebrates with students, while Emma Kivanch, Liam Shum, and Beth Byer admire a colorful mural of a reef painted by the students on the wall inside the school. We've been reaching out to schools in the Dominican Republic to work with them in educating children about ecology and the value of preserving their reef. Maybe in the future we'll be able to work with Dominican and Chicago area schools and help them create their own conservation projects. Reef Check in the Dominican Republic has been working with locals and communities to establish marine protected areas. Pictured here is La Caleta, a self-sustaining effort with local folks running a micro-enterprise called El Carry. The Coral Reef Regeneration team supported the initiative in La Caleta since our first year by diving there and helping plant a coral nursery to collect Reef Check data. Team members also participated in a local competition to capture lionfish. If you want to help, visit us at cr2chicago.weebly.com.
Our planet is dying, and we need to help it. We can accomplish this if we collaborate and get involved in conservation, as we are doing with the CR2 project. You, millennials, and your supporters can get involved through methods such as open data, and you can set up databases to further local education and global education about these invaluable natural resources we have. We hope that our work with the Coral Reef Regeneration Project will serve as an inspiration for how you can make a difference locally or globally, and how you can save the reefs, the oceans, the earth, if we work together. Thanks to all who make this effort possible.